Okay, so let's move on to addition. Now, when we're modeling addition, the addition itself is an actual motion on the algeblocks. The addition is placing. So, if we have, as we see in question 1a, in question A on page 7, 4 plus 2, we have two parts to addition. We have the start, and we have the change. So the start is the beginning, is what we start with on our mat. So let's bring 4 blocks. This is our start. And we're going to have to add 2 more. Now, the change is what I'm going to actually represent here. Oops. I'm going to start come on. How do we do this? Nope. There we go. I'm going to represent the change down here. This is what I'm going to have to add to my 4. And I'm going to add it to the positive side because I'm adding a positive 2. So let's do that. That part is the addition. So if we do that again, what we're going to do is we're going to take this and place it on here. Place or add the 2 blocks to the mat that we have. So what we're going to do is we're going to take these 2 blocks take these 2 blocks, nope, and add them. All right. So for question B, which is -3 plus a -2, well, if we were using our standard methods for adding integers, we would probably be starting to think, well, we're adding, the signs are the same, so it means we keep the sign and then we add the absolute values, and all of that is extremely procedural. If we actually are, and factual, if we actually are going to be modeling it visually, we can explain it in exactly the same way as we did before. Here's a start, here's the change, and our operation is addition. So we're going to start with -3, and we're going to place a -2. And let's see what happens. So we're going to start with -3. Okay. And we're going to get ready to place, let's get this a little bigger, a -2. There's 1, and there's 2. I'm going to place the -2. So that motion of adding was actually the placing of the -2. Now let's read off the value of that. What does that give you? It's the negative, and there's 5 of them. So it's a simple visualization with a fairly simple process. Now, shall we try the situation where the signs are opposite? Let's try C. -6 plus 5. So we're going to interpret it the same way. -6 is the start. The 5 is the change. And we're going to be adding. And adding is the placing. So let's see what we can do. I need to figure out how to do this better. 1, 2, 3, 4, 5, and 6. So, and we need to add 5. Now, let's get our 5 ready. 1, 2, 3, 4, 5. Now, and those 5 are the change, and where are we going to add them? We're going to be adding them to the positive side because the change is positive. So let's add, I'm gonna have to do them piecewise. All right, so now we have a mat with, what happened was we had the -6 first start and we added 5. What do you notice about this? We have some 0 pairs, don't we? In fact, we have 5 of them. So if we wanted to simplify this, after the 0 pairs, our answer, the value of our mat would be -1. So without worrying about signs being different, do you the same or different? Do you add or subtract? Do you keep the sign or you change the sign? The sign of which? All of this, all of those rules actually become irrelevant because what you're doing is you're seeing exactly what this would look like and where the 0 pairs are and what exactly is happening when you're simplifying those. So let's go back to our handout and let's look at this addition. Just so that you see how I draw the addition, we're going to have the start. This is going to be our add or place. This is our change. So we're going to start with 4 and we're going to be adding 2. And generally I try to circle or highlight or something what the addition is. So we're going to be adding 2 and the overall is going to be 6. So it would be similar for B. Let's look at C. We started here with -6. We're going to add our change. So we're adding, we started with -6. We're going to add our change. Okay. And now we need to look for 0 pairs. Well, there's 6 on the left and 5 on the right. 5 of those on the left and right can pair off to be 0 pairs, and what's going to be left is -1. Let's take a look at D and do that together. So this is our start. We're going to add or place. This is our change. So we're going to start with 3, and we're going to add or place 4 on the negative side. That's what we added or placed. Now, how many 0 pairs are going to be if there are 3 on the positive and 4 on the negative now? Well, we're going to be able to pair off 3 of those. So -1 is going to be the answer to that particular addition. So we were just working on adding integers. Now, how different or how much of a jump is it to actually start adding polynomials? Now, I'll leave E for you, but let's try to look at F. So remember, this is the start. We're going to add this much. So the start is -3k. We can define this rectangle to be k. That means there are going to be 3 of them and they're on the negative. Still remember that this is the type of rectangle of the block, This is the number, and this is the location. And we're going to be adding negative 2k squared. Well, if those are k's, then the k squared should be a square of that size. And there are 2 of them, and they're on the negative. Now, let's simplify this. Can we simplify this any further? We really can't, because there are no 0 pairs. Everything is on the left-hand side. The best we can do is write it out as the without the addition, is just minus 3k minus 2k squared. But really, there are no 0 pairs, so we can't be simplifying anything. There's still no need to be talking about like terms and to be looking at those procedures. However, in this situation, I'll leave you to do G on your own, but in this situation, if we talk about the x squared being the square of that size, we start with a negative x squared, and we're going to be adding 3x squared. So we're going to be placing 3x squared. So if x squared was a square of that size, then I need to place 3 of them onto the right-hand side. And that's my change. And now, what do we have? If you look, we actually have a 0 pair here, because we have 1 negative x squared and 3 positive x squared. One of those x squareds will pair off into a 0 pair, so the answer will be 2x squared on the positive side. And again, notice there was absolutely no conversation about like terms and drilling that into the students' heads procedurally. All of this is visual, and all of this is very easy to understand once the kids are comfortable with the Algeblocks. So let's see what we can do with some of these. So if we are still modeling this as the place, this will be our start, and this will be our change. Now, to start, we have 2w minus 3. Let's say this is our w. And minus 3. And what we need to add is minus w and plus 5. That's what we're going to be placing for addition. That's going to be our change. Let's go searching for 0 pairs. Do you see that this is a 0 pair? And we've got these 0 pairs. So the 0 pairs leave us with, 1 W positive and 2 singles. So if we are looking at how these kids will be thinking, they'll be saying, well, I have 2 W's on the right in the positives and 1 W in the negatives. So what am I going to do? One of those W's will pair off, and I'll be left with, into a 0 pair, and I'll be left with a positive W. And for units, I have 3 on the negative and 5 on the positive. 3 of those will make 0 pairs, and I'll have 2 left on the positive. And again, there's no need for conversations or drill about like terms. Now at this point, you need to pause the video, and you can solve J, K, and I on your own and see what you can do. Make sure that you model it with the actual Algeblocks if you have those handy, or with the virtual manipulatives, and then draw them out here. And then you can unpause me once you're done. All right, so let's take a look. Hopefully you've filled out some of these. Let's take a look, and we'll do example I together. So this is going to be our start. This is the place, and this is the change. So let's see, minus 3y squared. Let's say that the y squareds are going to be squares of that size. Okay. And minus 2y. This is going to be what we start with. And what we're going to add is minus 5y. 2, 3, 4, 5, and minus 6. This is what we added. All right, and let's simplify this as much as we possibly can. Where are the 0 pairs? There are no 0 pairs because everything is on the negative side. So we don't have any 0 pairs, but we can certainly look at simplifying some of this stuff. So we do have minus 3y squared. Now, how many y's do we have on the left-hand side? Left-hand side, and we have 7 of them. And how many singles do we have on the left-hand side? And we have 6 of them. So again, you see the simplification becomes fairly visual. So we don't have to be worried about, well, the y's you can add, but not the y squareds, and why, and for what reason. Kids that have gone through studying algebra and polynomial operations through Algeblocks have a slightly different way of thinking. So kids that have been studying like terms, combining like terms, will go through a process when they're faced with this particular question. They will say, all right, open up the parentheses first, and we're going to model this. Okay, so open up parentheses. The fact that it's a plus means we don't change the sign. And then we're going to underline like terms. And then the negative 12x squared and plus 15, we have different signs. So we subtract. So we have 3x squared, and we keep the sign of the bigger value. And then 15x and negative 17x, we have negative, the bigger value is negative. They're all different signs. So we're going to subtract. So that's going to be the thinking of a student who's memorized the procedure. Now instead, what I'm going to do right now is erase all of that. And let's think about how a student who has done Algeblocks is going to be doing this. They're not going to be looking for 12x squareds and 27x squareds to put on the mat. They're going to be visualizing this. And the way they're visualizing it is they're going to say, all right, I'm going to have x squareds. So the yellow squares, let's say 12 of them on the left. And so 12 yellow squares on the left and 15 yellow rods on the right. And then I'm going to place 15 yellow squares on the right, 17 yellow rods on the left, and 9 green squares on the right. So if I just focus on the yellow squares, I'm going to have 12 on the left and 15 on the right. Well, 12 of those will be 0 pairs. They'll pair off, leaving 3 unpaired here on the right. Now, if we look at the x's, I'm going to have 15 of them on the right and 17 on the left. So if I pair them off with 0 pairs, there'll be 15, leaving 2 on the left. And the 9 is not going to go anywhere. There's no 0 pairs. So you notice that the thinking here is going to be much more visual and much more based on understanding and actually being able to model the expression. So I'll leave number 2 for you. When we come back, we're going to start talking about subtraction.